Okay, so if you're in Calc 3, there's a chance that maybe you could use a little refresher on your derivative rules. So first of all, we just have some basic rules. So I don't think you need to know every single derivative rule. I mean, it'd be nice if you did for Calc 3, but the ones that I find are the most common are the ones that you see here. So you can just pause the video if you want to read them over. So I have this whole list in just like a challenge yourself form where you can quiz yourself. So if you go to divideandconquermath.com, you can download this. You need to be able to do this whole list like pretty quickly by yourself. So if you can't, I find that you don't have to practice this for that long to get it back in your system, but this will become a real thorn in your side if you don't remember this set of rules, okay? So that's the first thing that I want to say. I'm not going to go through all the rules, you can read them. But then what I'm going to do is I also just want to do a few basic derivatives just in case it's been a minute. So these are kind of common things that I've noticed you have to do in Calc 3. So for this first one, so we're going to take the derivative of cosine of 5t. Okay, so the thing to recognize here is that we really have two functions. So we can't just take the derivative of cosine 5t as is, because the idea here is that, so for the cosine function, I only have a rule for cosine of x. I don't have a rule for cosine of 5t, I guess in this case. So this I'm going to treat, so you kind of want to notice where are your composition of functions. So this is kind of like your outermost function, and I think of this 5t as your innermost function. So I think of this as I have two functions that are being composed together. I have the cosine t on the outside, and then we have the 5t on the inside. I don't have the rule for that here, but I'm assuming if you've taken calculus before, you can find the derivative of 5t. Okay, so what this is really counting on is that we use our old pal, the chain rule. And like I said, I find every once in a while, I think people might just forget this. So the idea of the chain rule is you figure out how the functions are composed. So if you look at this, what I'm interested in is, so what is the outermost function? That's our f of x. And then what's our innermost function? And so if you look at this, you take the derivative of f on the outside, you leave the inside function intact, and then you multiply by the derivative of the inside function. So if I go in that order then, so I take the derivative of the outside function. The derivative of cosine is negative sine. And then remember, so the chain rule says, so right, if we look at this, take the derivative of the outside, leave the inside intact, and then multiply by the derivative of the inside. So I'm going to leave this inside function intact, and then I'm going to multiply by the derivative of 5t, which is just 5. So then I can just rearrange all of this. Oops, I didn't have my little prime sign there, sorry. So this is going to be minus 5 sine of 5t, okay? So let's do that again. So let's do that for e to the negative t. So in this case, I only know the derivative for e to the t. So if you're just rusty on the chain rule, I would strongly suggest you pause here just to make sure that you try this on your own. Okay, so my outermost function is going to be this e, and then this to the negative t, this is going to be my innermost function. So taking the derivative of the outside, this is e, and then I just leave that inner function negative t alone. And then I multiply by the derivative of negative t, so that's going to be negative 1. So this is negative e to the negative t when all is said and done. Okay, so next up, let's work on our product rule. So for our product rule, so you're going to take, so I've got two functions being multiplied together, so you just want to identify those. Take the derivative of the first, leave the second alone, then leave the first alone, and take the derivative of the second. So my two functions in this case, I have t and I have sine of t. So first I'm going to take the derivative of t. So the derivative of t is 1, and I leave sine of t alone. Then I leave t alone, and I take the derivative of sine of t, which is cosine of t. So when all is said and done, I get sine t plus t cosine t for my derivative. Okay, so once again, so I would recommend that you just try this one on your own if you're a little rusty on your product rule. So give it a try, hit play when you're ready. So here's one function, e to the t, cosine t will be my other function. So I'm going to have that this is e to the t, the derivative of e to the t is e to the t, so this is e to the t cosine t. Then I leave e to the t alone, and the derivative of cosine t is negative sine t. So I'm left with e to the t cosine t minus e to the t sine t. Okay, so next I've got t squared minus 1. Oops, that should be over natural log of t, sorry. Okay, so t squared minus 1 over natural log of t. Okay, so this is going to be your quotient rule. So I would recommend, you know, if you're a little rusty on this, I would try this totally on your own first before you watch me do it. Then hit play when you're ready. Okay, so first I take the derivative of the top, which is 2t, and I multiply that by the bottom. Then I leave the top alone, and I multiply by the derivative of the bottom, which will be 1 over t. And so all of this is going to be over the natural log of t squared. And so now I would like to write this without any fractions. So this will be 2t times the natural log of t minus t squared minus 1, all of this over t, times the natural log of t squared. Now to get rid of the fraction, what I'm going to do is I'm going to multiply everything on top and on bottom by t so that I can get rid of the fraction here. So I'll make a little space. And so let's see, this is going to become 2t squared natural log of t minus t squared minus 1. So I can rewrite that really as minus t plus 1. I'll just get rid of the parentheses. All of this over t times the natural log of t squared. Okay, and finally, so I have the function cosine cubed of t. So for this one, I'm going to find both y prime and y double prime. So starting with my y prime, so this is your classic chain rule. So in this case, so the important thing to kind of view here is that this cosine cubed t can be rewritten as cosine t cubed. So the outermost function here will be the 3. So I bring the 3 down and I subtract it. So this will be 3 times cosine squared t. And then I multiply by the derivative of t, which is going to be, or the derivative of cosine, which is going to be negative sine t. So my first derivative is negative 3 cosine squared t sine t. And now I have to find my second derivative. So now for my second derivative, so we've got both our product rule and our chain rule all kind of hanging out here. So first I'm going to take the derivative of this negative 3 cosine squared t. So again, I'm going to bring the 2 down first. So this is going to be negative 6. So subtract 1 from that exponent. So this will be, so subtract 1 from this squared. Okay, so that's me doing the outside derivative. Now I have to multiply by the derivative of the inside. So the derivative of inside is, what is the derivative of cosine? So that's negative sine. And then remember, this whole derivative here then has to be multiplied by sine t. So these are kind of separate things. Okay, so that's the first part. So I took the derivative of this function and I had used the chain rule. Now I need to just take the derivative of this function. So this is going to be minus 3 cosine squared t, so leave that alone. Take the derivative of sine t, so that's going to be cosine t. And I'm kind of running out of space here, but I think I can cram this in. So this will become 6 cosine t sine squared t minus 3 cosine cubed t. Okay, so that's it for this video. If you found this helpful, consider hitting that like button or that subscribe button. Hopefully I'll see you guys in another video. Bye!